Hello, today I will talk about molar mass and molarity calculation. And I first talk about skeleton diagrams, molecular formula and structural formula of some molecules. I will show some examples. Then I will also make some molarity calculation for liquids. And we have to use periodic table to make some calculations, since molar masses of the compounds depends on the molar mass of the elements, and we can see the molar mass of the elements in this periodic table. For instance, hydrogen molecular mass is 1.008 gram per mole, and we can see other molar mass of the elements in the periodic table. So first question, what is the molar mass of CH3OH? CH3OH is methanol, and it is the simplest alcohol. CH3OH is molecular formula. We write all the elements in molecular formula, and we can see these groups completely. And also we have other type of formula, which is skeleton formula. It's just a line and OH. So the end of the line represents the CH3, and this line is bond itself, and this is the OH group. So this is called as skeleton formula. And the third formula type is a structural formula, and we write all the elements and we show the bonds. Lines represents the bonds. These are the bonds. And we show the elements also in structural formula. And the question was, what is the molar mass of the methanol? And the molar mass represents by big M. So this is the molar mass of the CH3OH. We know the molar mass of each element in periodic table, and molar mass of the methanol is the sum of all the elements in the methanol. We have one carbon. We need to know molar mass of carbon. We have 3 hydrogen of the CH3. It comes from CH3. We have 1 oxygen, and we have 1 more hydrogen. To make it easier, we can sum up the molar mass of the hydrogen, and we can make it 4. We have to know the molar mass of carbon, hydrogen, and oxygen. Molar mass of oxygen is 16, carbon is 12.01, and hydrogen is 1.008 gram per mole. To calculate the molar mass, we have to make the calculation. I will just write the molar mass values of the hydrogen, carbon, and oxygen. Then we can calculate. 1 times 12.01 plus 4 times 1.008 plus 16.00, and our mass is 33.042 gram per mole. We can use 2 decimals after the point, so the correct value should be 33.04 due to the significant figures. And the other example is this molecule. The name of the molecule is phenol. And we want to calculate its molar mass. And this is a skeletal formula of this compound. However, we have to know the total number of carbon, hydrogen, and oxygens. So I want to write a structural formula of this compound. So for each corner, we have 1 carbon atoms. There are carbons here. Carbon, 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 and carbon here. And there are double bonds and 1 oxygen and 1 hydrogen. Carbon makes 4 bonds, so that we have hydrogen for the carbons. But we don't have hydrogen for this carbon. The reason is that carbon had already made 4 bonds, so there is no hydrogen for this carbon. So molar mass of this carbon is equal to 6 hydrogen atoms, 6 carbon atoms, and 1 oxygen atoms, and we can write it. Molar mass of the phenol should be equal to molar mass of hydrogen. There are 6 of them. There are 6 carbon, and there is 1 oxygen. If we write the molar mass of the hydrogen, carbon, and oxygen, it will be 6 times 1.008 plus 6 times 12.01 plus oxygen. And we can calculate it. 6 times 1.008 plus 6 times 12.01 plus 16. And the answer is 94.11 gram per mole. This is the molar mass of phenol. And I want to give some information about phenol. Phenol is colorless liquid, and density of phenol, it is about 1.07 gram per centimeter cube or gram per milliliter. It is the same thing. And the melting point is 40.5 Celsius. at the boiling point, (181.7 Celsius). Let's say, what is the molarity of 100 milliliter of phenol at 55 Celsius? So we have 100 milliliter of phenol in a beaker, and we wonder molarity of the sample. How can we calculate it? So firstly, we have to know the molarity of the, so molarity is number of moles over total volume of the sample, and the unit should be mole over liter. We have already calculated the molar mass of the phenol, but we have to know the gram of our sample. How much gram we have? We have 100 milliliter, but we have to convert it to gram, and so we have to know the mass of the phenol in our case, and mass equals to 1.07 gram per milliliter times 100 milliliter, and it will be equal to 107 gram. So in our sample we have 107 gram of phenol. But how much more do we have? So we have to know the molar mass of the phenol, and we have already calculated it, which is 94.11. To calculate mole of the phenol in our sample, we have to divide it molar mass of the phenol, since this is gram and this is the mole. And if we do this calculation, what will we obtain? 107 over 94.11. So we have 1.13 mole of the sample. If I want to calculate the molarity, then I will just divide the mole of the sample to its volume, which is 100 milliliter. The issue is that we have to convert 100 milliliter to liter, and 100 milliliter is basically 0.1 liter, since 1 liter is equal to 1000 milliliter, right? And if we make this calculation, the molarity of phenol is 11.3 molar. We can do the same thing for the water, and water is H2O. We have 2 hydrogen, and we have 1 oxygen. And we know that density of water is 1 gram per centimeter cube. And the molar mass of the water will be 2 times 1.008 plus 16. We can calculate this number very quickly. And it is 18.016. So this is molar mass of the water. Let's say we have 1 liter of water. We have 1 liter of water. Its molar mass should be equal to 1 kilogram or 1000 gram. And molarity again, mole per liter, or N over V. We just need to know the number of moles in 1000 gram of water. So I want to calculate the number of moles of water, 1 liter of water. And we have 1000 gram of water, and it is 18, approximately 18, but we can write 18.016 gram per mole. Right? And mole comes here since it is 1 over mole. And the answer will be 1000 over 18.016, 55.5. 0.5 mole. So molarity is mole per liter, and our sample, we assume that our sample is just 1 liter. We have 55.5 mole and it is 1 liter. So 1 liter of water, or molarity of water, is 55.5 mole per liter. Why this kind of calculations are important? Since sometimes we have to know the molarity of some samples to make the required solutions in the laboratory. If we don't know their molarity, then we cannot calculate the required amount of sample. Therefore, knowing the molarity of some liquids are very important. And if you have any questions, you can ask them in the comment section. And thank you.